So we know that in the geological past, there have been periods when CO2 concentration has been much, much higher than it is today, more than 1,000 parts per million. And the Earth has been very, very warm during those time periods. So when scientists oftentimes say, look, the world is warming very fast and we're the cause, sometimes we get the rebuttal, well, but the Earth has always gotten warm. And it's true. And I'll show you some evidence here in just a moment. But the problem is it's warming much faster than it has in the past. And it's going to cause some changes that we might not be happy with. Now we know from recent work the last 2 or 3 decades by a wide range of people that Earth has natural cycles built into it where we get warming and cooling periods on the Earth. And most of the time these cycles are generated by variation, cyclic variation, in how much sunlight hits the Earth. And most of this cyclic nature of the sunlight hitting the Earth is driven by the fact that the Earth wobbles when it spins, that its tilt changes, and that the ellipse of the sun doesn't stay the same size. So there is variation, natural variation in how much sunlight hits the Earth. And when we have a lot of sunlight hitting the Earth gets warmer. And when we have not much sunlight hitting the Earth gets colder, and we have ice ages. So most of this work here was elucidated by a Serbian mathematician, Milankovic, and these cycles are now referred to as Milankovic cycles. And we now know that these cycles are highly correlated with the temperature of the Earth and things like ice ages. So yes, the Earth goes through cycles. We have hot spells and we have cold spells. According to these cycles here, we ought to be entering an ice age right now. We're not. Why not? Well, for whatever reason, we're staying warm. One of the reasons is an increase in atmospheric CO2 concentration. Down the road at Ohio State, there's a man named Lonnie Thompson. He's one of the scientists who is most responsible for showing that CO2 concentrations in the atmosphere drive global warming. And he and his team have done this by going down to Antarctica and going to Greenland and drilling for ice cores and bringing these ice cores back. So here's a picture of somebody drilling down into the glacier. And they come back with these ice cores. There's a whole storage facility, millions of dollars worth of ice cores at Ohio State down the road, where they have these ice cores that go all the way to the bottom of Antarctica. That's about 5,000 feet of ice. And they pull these up. They can take that ice out under sterile conditions, cut it, chop, 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 and then measure the gas concentrations in the bubbles of the ice. And no, we have ice records that go back about 800,000 years now. 800,000 years over the course of several ice ages. And we have temperature proxies for this ice. So there are isotope signatures in the ice that can tell us how warm was the world at the time and how cold was it. And we can match up. We can line up the temperature signal in the ice cores and compare that to the CO2 concentrations or the methane concentrations or the dust levels, anything we want. And when you do that, you find that there's an extremely high correlation between how warm and how cold the Earth was and how much CO2 we had. It's almost a 1-to-1 correlation. For this type of work, Lonnie Thompson was awarded the National Medal of Science. So using those sorts of data, scientists can now go back in time and ask, well, how cold was it? And how hot was it back a ways, 1,000 years or whatnot, 800,000 years? So we have direct measurements or proxy measurements back. We have direct measurements where humans have been measuring global surface temperatures with thermometers. They go back about 1850. And you can see here we have direct measurements of the temperatures across the surface of the Earth, different weather stations from about on this graph, 1880 to the year 2000. And you can see if we put a line through the running average, that we've gone up. You can't see the units in the back, but the average temperature across the whole surface of the Earth, where we have weather stations, thousands of them, if you add up all those numbers and calculate an average, those direct measurements have gone up about a degree since 1880. A degree, that's not much. But you know the difference in Earth's temperature, average temperature, between warm spells when we didn't have an ice age and when it was an ice age? About 4 or 5 degrees. 4 or 5 degrees doesn't sound like much, but it can change a lot of things. So we've warmed up about a degree in the last 100 years. And if you take indirect measurements, things like isotope signatures in wood, we can go back even farther. So these are secondary measurements. And here's a trace of temperature from the year 1000 all the way up to the year 2000. And you can see we have variation. The Earth is never the same. There's always variation. But we had a more or less constant temperature from about the year 1000 until about the year 1900. And then things started to shoot up. Now this graph's already out of date. If you plugged in data from the last decade, the line would be even higher now because we've had so many warm years the last 10 years. So we're starting to see the effects of pumping all that CO2 and methane into the atmosphere. So far, the effects are not a big deal. 1 degree C is nothing to worry about. The worry is if it gets up to 3 or 4 or 5 or 6 degrees Celsius, then we have something to worry about. All right? So the climatologists, there are a number of major groups across the planet who use really large, sophisticated climate models to ask, if we have this level of CO2 in the atmosphere, what might it do for average temperatures across the globe? And when you read in the newspaper in the morning some report about how scientists are predicting that the Earth will warm this much and this fast, it's coming from all of these groups, and it goes through sort of a clearinghouse called the Intergovernmental Panel on Climate Change, the IPCC, and they use an average of all those groups. So NOAA has a big group, and Colorado has a big group, and England has a big group. And all of these groups, their models are slightly different. It's pretty darn hard to project weather 2 weeks in advance, isn't it? So you can imagine how difficult it is to project what the climate will be in 100 years. You're asking an awful lot. So the models vary a little bit, but when you read in the newspaper that the projections are for a 5 degrees Celsius increase in temperature in the next 100 years, it's coming from averaging all these models, okay? And that's what's reported in the newspaper, an average. Because the models differ a little bit, and the farther you go out in the future, the more slop there is in the estimate, and you have to take it with a grain of salt. But they all are predicting increases in the range of 2 to 6 or 7 degrees Celsius on average, all right? I'll come back to that in a minute. Average, but there will be winners and losers, all right? And it's one of the key themes. The key things to remember from my talk today is there are going to be winners and there are going to be losers when we have global climate change. So we know that average temperatures are going to go up as a consequence of burning fossil fuels. Some places around the globe will not be touched much, and other places will warm up a lot. So here are results from one of those models. This is from the Hadley Center in England. This is just an example. So the point here is just to note that there will be places that get really warm and there will be places that don't warm up so much. And in this model, they projected where would the warming happen. And in orange are the places where it's expected average temperatures across the year are going to go up about 10 degrees Celsius. That's about 20 degrees Fahrenheit. Holy moly. And you can see that the biggest increases are going to be in the Arctic. So all that permafrost is going to melt. It's already happening. So roads are sinking in Alaska, for example, because the permafrost that underlies those roads is melting. But we see a few other hot spots too. Africa, Central America, India. Now these are places that really don't need to be warmer, do they? India is oftentimes referred to as the biggest ecological disaster waiting to happen on the planet. The last thing India needs is to be warmed up another 10 degrees C. And you'll notice that towards the equator, where we have blue or light green, almost no changes. So the equator in the middle of the ocean, it won't warm up much. The latest projections are that agriculture, especially in the southeast U.S. and in the Corn Belt, and we're part of that, is really going to be hammered. And we may be growing our corn in Canada in 100 years. Well, if the world gets warmer, then things are going to start melting in terms of sea ice and glacier ice and snowpack, and that's going to raise sea level. And so scientists have done a lot of modeling to project where will we get sea level changes and what parts of the world will it impact. Here's an example from NOAA, where they've looked at what would happen if sea level changed a meter, increased a meter, or 2 meters, so 3 feet, 6 feet, what is that, 4 meters, so 12 feet, 8 meters, 24 feet-ish. You can see that if sea level goes up 3 feet, coastal Florida, Louisiana in red start to feel it. They're already feeling it, by the way. Sea level is already increasing in those areas. If it goes up 2 meters, you'll notice we start to lose the tip of Florida. If it goes up 4 meters to 8 meters, 24 feet, then we lose a big chunk of Florida and a lot of the eastern seaboard. We know from the geological record that in the past, when we did not have Greenland covered with ice and western Antarctica wasn't covered in ice, that this was how high the oceans were. Latest reports are that the western ice sheet of Antarctica is starting to melt irreversibly. And the projections are, we don't know exactly, but in 200 or 300 years that might be completely melted, which means it's very possible that not in our lifetimes, but perhaps in our children's lifetimes, this is what Florida will look like. About 150 years, all right? But in 100 years, we're looking at changes on this order. So if you are invested all your money in coastal real estate in Florida, you might want to run down and divest and put your money in something else. Is the sea level rising? It sure is. We've been measuring it since about 1800, all right? And it's beginning to creep up. It hasn't gone up much so far since we've been able to start measuring it way back around, you see, 1860. But it's gone up a little bit. But we really hadn't started to melt sea ice and glacier ice up to this point, and now we really are starting to melt sea and glacier ice. I'll show you pictures. And so the projections, depending on whose model you talk about, sea level could go up 2 feet or 4 feet or 6 feet in the next 100 years. There's been a lot of research in the last few months suggesting that the earlier estimates of only 2 or 3 feet of sea level rise are way too conservative. The scientific community is shifting now and coming to it's not a conclusion yet, but they're beginning to feel like sea level rise is probably going to go much higher than 2 or 3 feet, 6, 8, 10, 12, that kind of rise in the next 100 years. All right, so how do we know the world is warming? Well, we can go out and see it. The USGS, U.S. Geological Survey, has a wonderful website where they've been taking photos of glaciers around the world, going back to that very same spot and comparing what's happening today to the old photo. So here's Sperry Glacier in Glacier National Park, Montana, 1930. They go back to the very same spot and you can see the glacier is gone. They've hundreds of pictures like this. Here are a few more, just because nothing is more forceful than what you can see with your own eye, isn't it? Right? A scientist can tell you this is happening or that's happening, and yeah, right. But if you can see it with your own eye, good gravy. There's McCarthy Glacier in Alaska. It used to look like this. Now it looks like this. This is not isolated. Glaciers and snow caps of mountains are happening. This is happening all over the world. Here's Kilimanjaro, 1970. Used to be covered with snow. Now it's not. All right? Same place, same time of year. Greenland is one of the big unknowns. So Greenland, most of the ice on the planet is locked away in Greenland and Antarctica. We know that half of Antarctica is not going to be melting. One half will, the other half won't. All right? But the other big reservoir of ice on the planet is Greenland, which despite its name is not green, it's really white because it's covered with about a mile of ice. Scientists have been measuring the rate of melt from Greenland. Here's 1992, and these places in red are where the glacier is melting. And here's where it's melting today. Melting on average. It's not growing, it's shrinking. All right? Now, they've done back of the envelope calculations. If Greenland melts, sea levels go up 10, 15 feet. There's so much water tied up in Greenland. Now, it's not going to melt in our lifetime, but it might melt in 200 years or 300 years. So we're creating a problem that somebody else has to contend with, future generations. Here's the polar ice cap. Right? In 1979, the polar ice cap was this big. And now it's this big. And the projections are that in a decade or two or three, we'll have summer times where we won't have any polar ice. The ice is melting so fast in the north. So we can see it with our own eyes. You don't have to believe scientists. You can look and see with pictures. All right, so when scientists first started to work on this problem, they were charged by the UN to work as the Intergovernmental Panel on Climate Change and start collecting data and assimilating reports. And they put out reports in 1996, and they said, well, it looks like there might be a human influence on global climate. Scientists tend to be very conservative. We're always qualifying what we say. So those first reports were, yeah, it looks like it might be warming, and maybe humans are having an effect. But then they go do more experiments, collect more data. In 2001, the report says, more evidence, it's stronger. The world's probably warming. Humans probably have an effect on that. 2007, the report says, when scientists use words like this, it means we're pretty darn sure. Unequivocal. It means that there's no debate. The world is warming. We're pretty darn sure that humans are the cause of this. In this report, very likely means at the time they're about 95% sure. All right? As you could expect, you would predict there will be winners and losers. In the US, one of the big losers will be coastal real estate. The losses in coastal real estate, especially Florida, along the eastern seaboard and the Gulf Coast will be huge. Hundreds of billions of dollars. Agriculture in the southern US is going to be a big, big loser. Billions and billions and billions of dollars. All right? Health and tourism costs. Tourism will go down and health costs will go up in the southern US. All right? I oftentimes kind of use this analogy for my students. Right? If we're causing a problem from CO2, that's just pollution. If we have less pollution, where's the downside to that? To having less pollution? Is there a downside? Well, until recently, there's been a lot of arguments from certain sectors of the economy that the downside would be very expensive to not use fossil fuels. But the latest economic studies suggest that that's not true. And that the cost is going to be so huge we might want to start dealing with it. When we have a problem in life, is it better to deal with that problem right away or let the problem fester and the problem get worse? Which costs more to fix? I oftentimes tell my students, we have a problem, we fix it right away, the costs are smaller. We let the problem grow, then the cost to fix the problem becomes huge. And that's what the economists, bipartisan economists, are telling us. It's not a Democrat versus Republican thing. All right? The World Bank just came out with a big study saying that it will actually help the global economy if we start making changes now and embrace new technologies. It will actually make us richer and grow the economy more than to resist changing and resist relying heavily on fossil fuels as we do.